We're going to consider the graph of the function f of x is x squared minus 9 over x cubed plus 8. So, the pole of the curve is the value that makes the denominator, the bottom, equal to 0. So that's just going to be x is equal to negative 2. The coordinates, so let's think about what values make the numerator equal to 0. So that would be 3 and negative 3. So we'll have 3, 0, negative 3, 0. And then if we make x equals 0, we're just going to end up with negative 9 over 8. So far so good. This is all quite straightforward. We now want to determine dy dx and state the coordinates for the stationary points to 2 decimal places where appropriate. Now this is a complicated function to work with, and it's going to give rise to complicated functions. So if you don't make maximal use of your calculator, you're not going to get very far, especially given the time constraint. So we want to differentiate this. So let's go into our keyboard and let's select the differential here. I want to do it with respect to x, and I'm going to input the function here. So I'm going to have x squared take away 9 over x cubed add 8, and then I'm going to execute, and we get this here. So that's our dy dx. So dy dx is x to the 4 minus 27x squared take away 16x all over x cubed plus 8 squared. Now we want this equal to 0. Well, we're not going to try and solve that equal to 0 manually. We're going to do that on the calculator. We're just going to grab the whole of that, bring it down to there, goes equals 0, and execute, and then we get some solutions. So we've got negative 4.87, and then we'll work out the y coordinate in a moment, and then we've got a negative 0.60, and we can scroll across and I can tell you the other ones are at 0. We know that one's 9 over 8 already because we know that was the y-intercept. And then we've got one at 5.47. So we want the corresponding y coordinates. Well, the easiest way when you're going to compute a load of things is to go to define. So what I'm going to do is define, and I'm going to define a function f of x. So I need to find the f of x, and I'm going to put that equal to the original. Remember, we're working out y coordinates, so that's going to be x squared minus 9 over x cubed add 8, and when it says done, it's done, and then we can go back to here and let's just work out f of negative 4.87. Probably should use a few more figures than that. You can always drag them from above, copy and paste them from above, it's not a problem. And that's negative 0.14, so 0.14, and the negative 0.6, so f of negative 0.6, and that's negative 1.11. We already had this one, and then we just do the same with the 5.47, and that is 0.12. And just looking at the time index on this recording, it's just at 3 minutes 55 now, which means it's appropriate for 4 marks. Now we're going to complete the table and hence state the nature of each stationary point. So you can see we know all the turning points will be 0 themselves. And I'm just going to split the table as well to make it clear what we're looking at with each one. So the signs of the gradient function dy dx or f dashed x will tell us what's happening at these turning points. So what I'm going to do is I'm going to grab f dashed x from here, I'm going to copy it, and I'm going to go to graph and table, and I'm going to paste it in here. I'd actually already done that. And then I'm going to produce a table. And as it happens, my table's already set up perfectly, but what you actually want is to go from -5 to 6 with a step of 0.5, and that means we cover all the values. And at -5 we can see that this is negative. We're not worried about the actual value. -3 we can see it's positive. If we keep going down, at -1 it is positive. At -0.5 it is negative. So that's negative there as well. At 1 it is positive. And we'll keep going down. So 5 is positive and 6 is negative. So what does all that mean? Well, this one goes -0 positive as gradient, so that one's a minimum. And the same sort of analysis tells you that one's a maximum, this one's a minimum, and this one is a maximum. Hence or otherwise sketch the curve, indicate clearly the intercepts, asymptotes and stationary points. Well, you'd be pretty crazy to try the or otherwise considering the amount of analysis you've done, so let's use the information we've got. And so straight away we can put on x is -2. We know that we have an intercept at -3 and we have one at 3. Now we're going to have a turning point here which is at -4.87 and -0.14. Now if you think about the curve between -3 and -2, remember it was x squared minus 9 over x cubed plus 8. So in this region this one's negative and so is this one, so it's going to be positive. This is going to go up the asymptote, up like that. Now because you've got an x cubed on the bottom and only an x squared on the top, the horizontal asymptote is going to be the x-axis, so this must come down, take its minimum here and then come back up towards here. Now in this region here, the bottom is now positive and the top would still be negative until we get to here. So it must come up from here. We know it's got a maximum here, it's got a minimum here, and then it's going to come up and it's going to go through here. So this one is at -0.60 and -1.11. That's this one. And then we need to make that look more like that's a minimum there, don't we? So let's just see if we can just change the shape of that a bit. So that is actually the minimum there. And then it comes up to here, like so. So this one is at 0, -9/8. Comes through there. It's going to take a maximum here and then come back downwards. And the maximum here we know is at 5.47, 0.12. So that's what it looks like. And of course you've got the calculator, so you can always graph it just to check that you've got things right.